What is optical fiber cable, and how does it work? What does a fiber optic cable do? The way in which we communicate has radically changed over the last 2 decades. Advancements in technology have led to a landscape where we can communicate with anyone in the world no matter where they are. And, more importantly, we can do this quickly and with minimal disruptions to quality. One of the driving forces behind this advancement is the availability of many fiber optic cable types. Fiber optic cables allow for a higher bandwidth and transmission speeds, over a greater distance than those achieved on copper-structured cabling. What is a fiber optic cable? What is meant by an optical fiber cable? A fiber optic cable is similar, at least in aesthetic terms, to an electrical or structured cabling cable. However, its method of operation is very different. Instead of transmitting electricity over its cable length, fiber optic cables transmit high-speed data via pulses of light. Subsequently, these are converted from and to electricity both ends of the cable. What are fiber optic cables made from? Cables are constructed of long, thin strands of glass fiber that are housed within an insulated jacket. Therefore, a fiber optic cable transmits light signals through its glass core. Depending on the specification of the cable, the light will either be sent via a LED source or a laser. LED is where a multiple large zone of light is shone down the cable. In contrast, a laser device transmits a signal laser light direct along the glass core of the fiber optic cable. Are all fiber optic cables the same? To the naked eye, fiber optic cables all look very similar, and the inner glass cores, being so small, look similar even though they range in diameter. Fiber optic cabling can vary in the following ways. The fiber cable can be either single-mode or multi-mode. The fiber cable can have a different number of inner cores. Categories of single and multi-mode can be categorized into subcategories of different performance capabilities. The outer sheath can be suitable for internal or external conditions. The outer coating can be armored, or surrounded by a corrugated steel tube, CST. The sheath can be PVC, LSOH or Euro-class fire rated. There are 2 main types of fiber optic cables. Single-mode fiber. Working with just a single light path, single-mode fiber can transmit signals over distances of up to 100 kilometers. The electronics required to work with single-mode fiber cables are expensive, and are most commonly found in telephony applications, local area networks and cable TV. Multi-mode fiber. These types of fiber optic cables differ to single-mode fiber cables in that multiple light rays travel throughout the cable. This allows connections to be simplified and present a cheaper option. However, due to the light dispersion that takes place, the range on offer in multi-mode fiber cables is much reduced. The distance on offer is usually around a maximum of 1 kilometer. How many cores in fiber optic cable? Fiber optic cabling works via a transmit and receive return path on separate cores, so 2 cores are needed for each connection. Standard office connections are usually 4 to 16 cores, and will depend on the number of connections required. Larger core sizes are usually installed in larger projects, or to allow for future connections. A design may call for separate connections between floors for network, CCTV, access, telephone and Wi-Fi. This would require a minimum of 10 core fiber, 5x2 connections. Fiber optic cabling in computer networking. The backbone of any good computer network should always be fiber optic cables. Communication in business needs to be quick and it needs to be efficient. And fiber optic cables allow both these conditions to be met. Large files can be seamlessly transferred between users, and communication via video conferencing can be delivered with a crystal clear, uninterrupted level of quality. And fiber optic cables are more than capable of supporting large numbers of employees. Therefore, fiber optic cables are a fantastic choice when it comes to setting up any computer network. Copper cables will be installed from the cabinets to the user outlets, and the fiber optic cabling will link the separate cabinets throughout the building or campus. Fiber optic cabling advantages and disadvantages. As with any product, a fiber optic cable comes with a number of advantages and disadvantages. Fiber optic cabling advantages. High bandwidth. Compared to other cables on the market, such as copper, fiber optic cables provide the highest bandwidth available for transmitting and receiving data. Small size. A major advantage of fiber optic cables is their small size. This not only helps you to save space, but allows for simpler organization of your network. Distance. Fiber optic cables are able to take advantage of their low power loss to transmit data over large distances compared to rival cables. Low error rate. The fibers within the cables are highly resistant to electromagnetic interference, so the risk of errors during transmission is significantly reduced. Fiber optic cabling disadvantages. Install issues. Fiber optic cable isn't the easiest material to install due to its fragility. Bending the cables can easily damage the glass fibers, and the thin jackets also mean that they are susceptible to being cut. Costs. The many benefits of fiber optic cables do not come cheaply. And, compared to copper cables, they are much more expensive to purchase. With these benefits, it is of little surprise that fiber optics are fast becoming the cable solutions for choice for businesses that want reliable, fast connections. For a free quotation, please visit our website, nmcabling.co.uk, or call at 01923888588.